All right, hi guys. We're Dustin and Jason. We work at Wingspan. This talk is because last year at ETE, Wingspan was here, and we're like, this functional programming stuff looks fun. And we didn't really know where to start. Because there's lots of like intro-level stuff, like talking about syntax, and then there's other stuff talking about like really advanced monad gymnastics. But like we just wanted to see some real code, and maybe you couldn't understand it all, but you could get like a feel for how the language would be. So that's what we're going to do. For this, we have a very simple CRUD application. Can you pull it up? It's a single-page application. We have a browser client that just has a bunch of really simple JSON web services. And we're going to go ahead and demo, click through it so we can see the data model. So this page here, you go in and you like it's an application for like project management. Like you can make a project and declare what technologies that you use on that project, or like.
This was intended as a collaboration for people in the arts.
So like this endpoint right here, I'm a user, I'm logged in. It's got all the list of all possible skills in the systems, and it's also the checked ones are the skills that I used. And then you can also go in and like set projects and stuff. You can do that. Oh, we're having resolution issues, aren't we?
Yeah, the Bootstrap toolbar doesn't render low res.
Tested on that.
Well, we'll just keep going. All right.
Oh, wait.
So this checkbox right here, you can see these checkboxes. It's powered by a JSON web service that looks like this. So like you've got a list of all the possible skills, all those checkboxes on the screen. And then each checkbox like has a name and then like an enabled state, the Boolean that says like, is it checked or not? Oh, it's back to the data model. Okay, so you can also declare a project. So like, excuse our sloppy application. We have a list of 3 projects defined in the system. The first project called foo is looking for, okay, yes, you've got a project called Quartet, which has this set of skills, are the skills needed for this project, and these Bongo and Binky are the people that are part of the project. It's like you have a team, it's like, oh, at work we have a project, these are the technologies we use, these are the team members. So this is just a CRUD application to manage this.
A user can join a project if they have the skills. And this is a list of projects that the user has not joined but has an overlapping skill with. So it's a pretty simple thing to understand.
Oh yeah, like a monster.com type of thing. Yeah. Okay. So this is the endpoint that we're going to live code first. This is what the schema looks like. Well, let's just go to here. This is a JSON endpoint. Okay, so in Scala, in the Play framework, we're using the Play framework, which is like a really easy to use way to build web applications. So the first thing that happens when you hit this page on his screen is it says, here's a list of all the possible URL endpoints that you can hit in this application. So this one right here, API list skills user picker, is a JSON endpoint. It takes GET requests and it maps to this piece of code right here, list skills user picker in this package. So if you make a request to here, it goes to this code. So let's go to that code, list skills user picker. So here it is. So I'm going to whack all this. Oops. So, oh wow, resolution really bad. Okay, so we have a function. This is in play, like how you say like authorization. So you have to be authenticated and you have to have a certain privilege. These brackets right here is just like an anonymous function. It's like the function keyword in JavaScript. So really this is just a function which is passed to this authorized action thing. You do this a lot in Scala. It takes 2 arguments, a user and a request, and this block of code will only be executed if like you're already authorized. So you can see here, we're using the type system. We've defined this case class right here. This represents the shape of our JSON payload, so it'll totally line up with this web service. You have an ID, a name, and enabled, ID, name, and enabled, and we're going to have a list of these. So you can see right here, the type signature is list of our payload, but it's also wrapped in a try. So this is just another way of you can like have really complex nested types in Scala. It makes this easy to do. This try means whatever code we put in here is going to catch all exceptions, and then instead of you have an exception that can be thrown, you're really going to return it like a tuple. So you're going to have something like if this value caught an exception, right here, you can access that exception as an object right here. Like we're saying, if failure means there's an exception, then return a 500 error and print out the exception. Or this try value can be something that succeeded. So here, well, we can unwrap the actual thing and serialize it to JSON. So in this way, like you don't have to throw exceptions, you can just return them through your return values. So JSON is going to live code with Slick.
Oh, we're going to implement this again.
Yeah.
You're not going to fill in that detail.
Nope. So right here would be a piece of code that gets a database connection and then returns a list of user pickers, or perhaps through an exception. And that's what JSON is going to code.
So
Collapse stack, right?
This is what you whacked.
Yeah. Don't you have some Slick stuff?
Well, I thought it was just going to implement it again.
Whatever you're ready to implement.
We're going to take this as read, because we already have the endpoint. What I'm going to show you is how this implements in Slick. In the Slick, excuse me. So I want to show you how this works in Slick. Slick is an attempt to create a view of a relational database that looks a lot more like collections in memory. It uses Scala's API for comprehensions. You guys might not have heard of that. And the details aren't so important, but the important thing is that Slick takes you away from SQL and into a more native code-centric way of viewing your database. In this function, we're going to get all the skills that exist in the system and all the skills that the user has and merge them together with a Boolean flag indicating whether the user has that skill picked in order to generate this list in the proper state. So moving on to the Slick code, we'll do it in this project. Let's take a look at Slick from the top down. In Slick, you indicate your schema in code using structures like this. Now, Slick provides 3 different APIs. We're using the one called the lifted API, which takes the values that will be in your database and wraps them in their own types in order to do its calculations. They also have a macro-based API, which isn't quite as far along, and that's why we didn't use it, although it looks nice because it uses the native types that would come right out of your SQL database. They have a third method, which we will show briefly, which is just basically interpolated strings as raw SQL. So you can always, in Slick, resort to raw SQL without having to say resort to JDBC. And if anybody's ever used ANORM, which comes with Play, you'll recognize that. It essentially takes raw SQL and has a record set parser that makes it very convenient to deal with record sets.
Right, so you can see that his Slick code lines up with this SQL schema. We've expressed the schema with the type system, so thus we can write Scala code. We can express our queries in Scala code, and they'll be type checked.
Right, so let's push this thing out of the way right quick and just go through the exercise of implementing it while we talk about the different things in there. So we want to teach Slick about our skills table. It extends an object called table, and here we give what's called, a tuple. For those unfamiliar with Scala, it lets you collect, It lets you collect a fixed length set of heterogeneous types in a thing called a tuple. Java programmers and other programs lament the idea that you have to create an ad hoc class just to return multiple values in a function. Scala lets you define them anywhere you like. And we indicate the name of the table in the constructor. This is the name it's going to use when it actually generates SQL. Gosh, I can't type today. Excuse me. Now, one thing that's missing from Slick is support for schemas. It's a little thin. It's only 1.0, so the solution in our case was to set the default search path in Postgres. Now we're going to model our columns, which let me just cheat here. Def. Def introduces a function, ID. Yeah, I could put column of type int. Excuse me. The column name, and this provides annotations like primary key and also auto increment. The way they actually handle this is interesting. Rather than trying to be completely generic, they seem to have a variety of parallel implementations. You can see that this one is intimately tied to the actual implementation of the database. The code should port if we use a different database, but we would have to have a different import. So they've threaded or specific database implementation through the whole thing, even though you don't explicitly see that. Our next column is name. It's of type, string.
Yeah, if you're paying close attention, my SQL schema doesn't line up with his. He has an int here.
Yeah,
we've
only been working on this for a week and we forked it already. I'll get rid of that stuff. So we have our columns. We don't need to go through the exercise of typing them all. This is a required function. I call it splat. Most people call it star. This is required to produce the exact same type as the tuple that was indicated in the database here. Now, Scala lets you overload operators, in case you don't know that, and most Scala APIs make heavy use of this. In this case, we're going to compose our projection off the already defined columns. Notice how we're making another function by an operator composition of yet other functions, a common idiom in Scala. When applied lightly, it's fairly understandable, but it can get complex quickly. In our case, we also have an auto-incremented ID here. How do we handle that when we want to insert and we don't have a value, obviously? So we can create our own projections. You can give it any name you want. I've been using this. Why not? Equals name and description. This projection over the table will be used in the case of inserts where we don't know the value, or we expect the database to calculate it for us. Like if you have columns with default values, they would go here. You would simply define a projection for every different way you want to insert data into the database. And we'll see that in use later. So there is our skills table. Moving on, we are going to, where is that method? List skills. Here's a good example of a function. I'll get rid of that guy. When you're dealing with Scala code, you obviously always have to have a connection in Slick, and Slick is called a session, and Slick has a variety of ways for managing sessions. You can create them from combo pool data sources, make your own JDBC connection, it's all fine. The way you pass them around, though, is with an implicit value here. In Scala, you can declare implicits, and the compiler will attempt to initialize a value and do a lot of things based on the context in which it finds that code. And so by declaring something implicit, you don't have to ever explicitly pass it in, and the compiler will attempt from the context in which it finds it to fill in the values for you. Very handy. So later on, if we want to make it a session explicitly or put it in thread local storage, none of this implementation has to change, and none of the client code has to change either. And we'll see a bit of the client code later. So when you construct a when you construct a query in Slick, you use a for comprehension. This is a structure for generating sequences of values or iterating over things. It's a very useful function with a lot of value. We simply declare the table we want to select from, and in a special block, we tell it what values we want it to produce. In this case, we're looking for the ID and the name. We're eliding the description. We could do that later.
So would it be fair to say that that generated select ID name from skills?
Yes.
Except type checked,
Yes.
Right, okay.
Later on, we'll see some actual SQL that Slick produces. You can make it produce something close to what you would have written by hand, but often the most intuitive way to implement it produces SQL that you might not necessarily have done by hand. But that's a beautiful part, right? So it abstracts you from the SQL, allowing you to do a greater variety of things. When we want to actually run it, we have to call some function like list. This runs the query. It also takes the implicit session. So you can see how session management is easy in code because you don't really have to deal with it once it's all set up. Having listed the thing, then we can use standard Scala functions to map over the results. In this case, we're going to cheat, and yeah. So in this case, as we map over the thing, we're simply going to match it to the tuple of ID and name and construct a new skill from those things, and we're done. So just to review, you simply name the table. If you wanted to select only certain things, you can put an if condition here. Again, this is a standard Scala control structure. But the way these control structures are implemented are with specifically named objects, functions off these objects. Slick has co-opted that mechanism to actually, instead of computing over a data structure, to do a static analysis and generate SQL.
Okay, so we've used the type system to type check our queries using Scala. Okay.
And it all checks out. And that's the beauty part of Slick, right? So once if your schema matches, everything you do in that schema will now type check against the type system. And it becomes a more integral part of your code rather than this escape into some weird language that returns some stuff that you have to just take on faith. Yeah?
Okay, so I'm going to write something very similar in Clojure now. Now, for fun, we're using DeTomic. So in a nutshell, this is just notes for me, you don't have to read this. So DeTomic is a immutable database. So you can think of Git. When you remove a file from Git, you actually declare a statement to Git that this file is no longer there. But if you travel back in time to a prior commit, like the file's still there. So like that's what an append-only database means. You can still remove things. You can still update things. It just means the past version is still accessible. So you can take my word for it that DeTomic is ACID just like PostgreSQL, which is the point. Like a lot of the NoSQL databases violate ACID by design. DeTomic does not. And then the biggest, most important thing is when you issue Git commands, you can say, I want to check out this commit, and you have all the data for that commit locally within your file system. So if you want to ask a question like, who changed this line? That would be like a query. Well, you run the query on your own machine. You don't have to go, like in CVS, you'd have to go somewhere else and ask some other machine to answer the question for you. In DeTomic, all of your storage indexes are in your local process. They're cached in each process. So when you do a read query, it's as if your data is in memory because it's already there. Like in the background, the data is being streamed to your database. So all your queries are